Okay, this is Unit 8, Lesson 5, screencast, I think, number 9. And we're starting with the Saffir-Simpson hurricane wind scale. Okay? Let's start actually at the bottom. If you notice, a tropical depression. This is a tropical cyclone that would be formed and organized, but the wind speeds are 38 miles an hour or less. Okay? If the sustained winds are at least 39 miles per hour, it becomes a tropical storm. Okay? And when it becomes a tropical storm, this is when it gets named. Okay? If wind speeds are sustained at least 74 miles per hour, then it becomes a hurricane. Okay, but then the hurricanes are classified according to intensity. So these are all hurricanes here. Okay. But a Category 1 hurricane, for instance, would have winds between 74 and 95 miles per hour. If a hurricane gets classified as a Category 2 hurricane, its winds are between 96 and 110 miles per hour. A Category 3, 111 to 130 miles per hour. A Category 4, sustained winds of 131 to 155 miles per hour. And a Category 5 hurricane are hurricanes with sustained winds, maximum sustained winds of at least 156 miles per hour. Okay? All right. Please understand that the Saffir-Simpson hurricane scale only is dealing with wind speed. Okay? Now, pressure, barometric pressure, also measures hurricane intensity, but it is not used to categorize storms. Okay? It is often sort of an additional measurement, but like I said, we categorize the storms based on their wind speed. Okay? Storm surge information is also important, but it's also not included in the Saffir-Simpson scale because hurricane size, which means like how far out do hurricane force winds extend from the center, local bathymetry, meaning that y'all remember that means like the topography underwater, basically. Topography of the land, hurricane's forward speed, angle to the coast, all of these things are going to affect storm surge. So storm surge is not a real good indicator of how strong the hurricane is. Storm surge, guys, is basically higher than normal ocean levels that are brought in with the hurricane. Okay, it can be many, many feet in some cases. Storm surge is typically what causes the most property damage and flooding and things like that. Okay. Yes, there are high winds that cause a lot of property damage too, but storm surge tends to do the most extensive damage. But bad the storm surge is going to be is a little bit harder to nail down because of all these other factors. Okay, how big is the hurricane, which means how far out do hurricane force winds extend? What's the local bathymetry like? What's this surface under the water looking like? What's the topography of the land looking like? What's the hurricane's forward speed, meaning is it coming in towards the coast? Is it coming slowly? Is it coming quickly? Etc. The angle to the coast. All that stuff affects storm surge. So really, we're just going to simplify it. The Saffir-Simpson wind scale, we're just using wind speed to categorize hurricanes. Now, storm surge and pressure drop and some of those other things are associated with the strength of the hurricane, but they're a little bit harder to nail down. Okay, so for instance, as an example, the very large Hurricane Ike, with hurricane force winds extending out as much as 125 miles from the center. That would be 125 miles from the center one way, 125 miles from the center another way. That means that the hurricane force winds have a diameter of like 250 miles, so that's huge. Okay. Hurricane Ike in 2008 made landfall in Texas, pretty much almost a direct hit for Galveston. Okay. Made landfall as a Category 2 hurricane and had a peak storm surge of 20 feet. Okay. In contrast, tiny little Hurricane Charlie only had hurricane force winds extending out 25 miles from the center, so its diameter was only about 50 miles across for hurricane force winds. That struck Florida in 2004 as a Category 4 hurricane, but produced a peak storm surge of only about 7 feet. Okay, so how bad the storm surge is going to be is a little bit harder to nail down, like I said. So we're just rating hurricane intensity based on wind speed. Okay. The strongest hurricane on record for the Atlantic Basin is Hurricane Wilma in 2005. Its central pressure was 882 millibars, which is only 26.05 inches of mercury. If y'all remember from all of the weather that we've recorded this year, normally our pressures are in the very, very, very high 29s, or they're like 30 point something. Okay, so this is very low compared to what it normally should be. And you remember when we did the atmosphere packet, we know that normal barometric pressure in millibars was that 1013. So this is way below. And remember, we were when we were doing our weather maps, we knew that our normal barometric pressure in millibars should be between about 950 and 1050, and that it was going to take something really wild to get it out of that range. Well, here's the really wild thing. Okay, hurricanes have central pressures that are substantially below what they normally would be. Okay, Wilma produced sustained winds of 175 miles per hour. Okay, so very low central pressure, very, very high wind speeds. Okay, you might be wondering why you haven't heard more about Hurricane Wilma, and probably the reason, well, there's probably a couple of reasons. First of all, there's a picture of Hurricane Wilma from one of the other pages. First of all, it hit in Mexico. It didn't hit the United States, but 2005 was also the same year that we had Hurricane Katrina hit New Orleans. We had Hurricane Rita hit the Texas coast, or right there at the Texas-Louisiana border. So we were dealing with a major mess and cleanup here in the United States with those two hurricanes. So when Wilma came along in the same hurricane season, Wilma was actually more powerful than the other two, but in some sense she kind of got overlooked.